Good day, viewers. Welcome to this tutorial. So in this tutorial, um, today we'll be looking at another question on electromagnetism. Okay, so the question before us is the figure below. This is the figure. Okay, the figure below shows the circular track of a positron moving in a uniform magnetic field. Okay, so this is the path of the positron. The positron is moving in a circle along a path. Okay, that is, it is describing a circle along a path. The magnetic field is perpendicular to the plane of the figure. So which means the lines of magnetic induction is perpendicular to the what? To the plane of, to the plane of the figure. All right, so the speed of the positron is 5.0 multiplied by 10 raised to the power of 7 meters per second. And the radius of the track is 0.018 meters. So we want to calculate the magnitude of the magnetic flux density of the magnetic field. Now, to calculate the magnitude of the magnetic flux density of the magnetic field, so we need to first identify the given values. So to identify the given values, okay, so we have the first one. Okay, now let's look at the values we are given. So we are given the speed of positron. We have the speed, we have speed of positron. Now speed of positron is 5.0 multiplied by 10 raised to the power of 7 meters per second. Then also we are given the radius of the track. So radius, okay, radius of the track. The radius of the track is given to be 0.018 meters. All right, so now we've been able to identify the two given values, but there are other values, in order for us to be able to calculate the magnitude of the magnetic flux density of the magnetic field. And the values are, we need the mass of the positron, and also we need the magnitude of the charge on positron, because the charge is moving along the track. You understand? Positron is what? Is a charge. So the charge on positron, that is the magnitude of the charge on positron. The magnitude of the charge on positron, okay, is the same as the magnitude of the charge on electron, which is the 1.602 multiplied by 10 raised to the power of minus 19 coulombs. Okay, now also, like I said, we also need we also need the mass of the positron. So the mass of the positron is the same as mass of electron. So we have mass of positron, okay, mass of positron is the same as 9.1 times 10 raised to the power of minus 31 kilogram. Now remember, mass of electron is 9.1 times 10 raised to the power of minus 31 kilogram. Just like we have mass of proton and neutron. The mass of proton is the 1.675 times 10 raised to the power of minus 27 kilogram, while the mass of neutron is the 1.673 times 10 raised to the power of minus 27 kilograms. So now we've been able to identify the values. Okay, we have the speed of positron, we have the radius of the track, charge on positron, mass of positron. Now we want to calculate the magnitude of the magnetic flux density. So to calculate the magnitude of the magnetic flux density, now we see that the positron is describing a circle along its path. So the path of positron, okay, which is circular path, okay, is because there is a force that keeps the positron moving in that path. All right, so the force that keeps the positron moving in the track is the centripetal force. Why the charge, the positron, which is the charge on the positron, okay, which is moving along the track, okay, we experience a force known as magnetic force. So the magnetic force, okay, will be equals to the centripetal force. So we're going to set we set this equals to this. So we now have the force on the moving positron, which is E, then VB equals to the centripetal force, which is mv squared over r. Remember, r is the radius along the circular path. Now, when we divide this equation by v, okay, the v will cancel out, this one will cancel out. So the equation now reduced to EB equals to mv over r. Don't forget that we want to obtain the value for B, which is the magnetic flux density. So we can write the formula for magnetic flux density to be mv over ER. Okay, mv over ER. That is the formula for the magnetic flux density. Okay, mv over ER. Also, don't forget that the force, the magnetic force, is equals to the centripetal force. All right, so now to be able to calculate B, so we're going to plug in the values, the respective values for the respective values into this equation. So we have mass of positron 9.1 times 10 raised to the power of minus 31. Okay, so we multiply by the speed of positron, which is 5.0 times 10 raised to the power of 7. Now we're dividing that by what? The charge on positron, which is 1.602 multiplied by 10 raised to the power of minus 19, then multiply by 0.018, which is the radius of the track. So let's multiply 9.1 by 5.0. That's going to be 45.5. Then multiply by, now when we combine the powers of 10, this is minus 31, and why this is 7. So minus 31 plus 7, that will be minus 20, minus 24. So all over, so what is 1.602 multiplied by, that is 1.602 when we multiply by 0.018. Okay, that will be 0.029. Okay, so we have 0.029 multiplied by, remember, we have 10 raised to the power of minus 19. Okay, now let's divide 45, okay, 0.5 by 0.029. Okay, that would be 1568 points. What we have B, okay, we have our B equals to 1568.9.97. Okay, now when we bring this guy up here, when this is taken here, taken to the top, to this, to here, it will be positive 19. So which means we have 10 raised to the power of minus 24 plus 19. Remember, the unit of magnetic flux density is the Tesla. All right, so minus 24 plus 19, that will be minus 5. That's negative 24 plus what? Plus 19 is what? Negative 5. So B will be 1568.97 multiplied by 10 raised to the power of 5, negative 5 Tesla. So multiplying 10 raised to the power of minus 5 by 1568.97, that would be, so the value of B would be 0.015, let's approximate it to be what? 7 Tesla. Okay, 0.0157 Tesla. And this is the what? The magnitude of the magnetic flux density of the magnetic field. That's the answer. Thank you.